Hi there, in this video you're going to learn about dilations. Your objectives for today are to graph dilations on a coordinate plane and to find the scale factor of a dilation. A dilation is a transformation that enlarges or reduces a figure by scale factor. So if you remember from when we did similar figures, we use the term scale factor. We're going to see what that means. If you're dilating from the origin, you will multiply each coordinate of the figure by the scale factor k. Okay, so in other words, you take an ordered pair, so x comma y, take each coordinate and multiply it by whatever your scale factor is. So in this case, we're going to call our scale factor k. A figure has vertices j, 2, 4, k, 2, 6, m, 8, 6, and n, 8, 2. Graph the figure and the image of the polygon after a dilation with a scale factor of half. Now, if you recall, scale factor basically tells you how big or small an image is in comparison to another. Okay, so here our scale factor is half. So our image is going to be half the size of my pre-image. Okay, so whatever image I start with, I'm going to take half the size of it. So I'm going to multiply each coordinate by 1/2. So I'm given these coordinates, right, these ordered pairs, I'm given them here. Okay, and I'm going to multiply each coordinate by 1/2. So 1/2 times 2, comma 1/2 times 4. So 1/2 of 2 is 1, right? And 1/2 of 4 is 2. So first, let's do that. Let's multiply each. Let's multiply each by 1/2, okay? And then get our new ordered pairs. So 1/2 times 2 is 1, right? And 1/2 of 6 is 3. 1/2 of 8 is 4. 1/2 of 6 is 3. 1/2 of 8 is 4. 1/2 of 2 is 1. Now, if you were to graph this right here, okay, 2, 4, 1, 2, 3, 1, 2, 4 is right here. Sorry. So we have J, K, M, N. This is your original image. This is your pre-image, okay? So then your image is right here. It looks like this. Notice this is half the size of this. If you don't believe me, check out the sides. This side is 2. This side is 1. This side is 1, 2, 3, 4, 5, 6 boxes long. This side is 1, 2, 3 boxes long. Okay, that's just a quick way to check yourself. This is 1, 2, 3, 4. Okay, well, half of 4 is 2. 1, 2. The image is literally half the size of your pre-image. All right, a triangle has vertices. A, 1, -2, B, 0, 2, and C, -2, -1. Find the coordinates of the triangle after dilation with a scale factor of 2. All right, so here my image is going to be 2 times the size of my pre-image. Why? Because my scale factor is 2. So the dilation is x, y changes to 2x, 2y, right? We're multiplying 2 to each coordinate. To dilate the figure, multiply the coordinates of each vertex by 2. So here's our first ordered pair. I'm multiplying each coordinate by 2. Okay, so 2 times 1 gets me 2. 2 times -2 gets me -4. My ordered pair again. 0 times 2 is 0. 2 times 2 is 4. Now, this is our next ordered pair, -2, -1. Multiply both by 2, and you get -4, -2. The coordinates of triangle ABC after dilation with a scale factor of 2 are A prime is 2, -4. B prime is 0, 4. And C prime is 4, -2. Sorry, -4, -2. All right, and just in case you wanted to see what that looks like on a graph, it looks like this. So in the green, we have our image. The blue, we have the pre-image, right? So that's it. Well, this is what we started off with. and then in the green is where our image is. So A prime is at 2, -4, B prime is at 0, 4, and C prime is at -4, -2. Okay, now really quickly, you can just kind of eyeball it and see that the one in the green is 2 times the size of the one in the blue. If your scale factor is greater than 1, it is an enlargement. See here? Our scale factor was 2. It was an enlargement. From blue to green, it enlarged. So think, if my scale factor is 2, the image will be 2 times the size of my pre-image, okay? If your scale factor is between 0 and 1, it is a reduction. So that's like this example. Half is between 0 and 1. So it is a reduction from our pre-image to our image. We are reducing it by half, okay? It is half the size. So my scale factor is 1/2. That is a reduction. If your scale factor is 1, guess what? Nothing changes because each side you're just multiplying it by 1, so nothing changes. How to determine scale factor. So the sides of an image of a figure being dilated are proportional to the corresponding sides of the original figure. To determine scale factor, you want to use the ratio, the side length of the image, okay, just in case we're not familiar with the vocabulary, in case we forgot. Image is the new figure that we draw. The pre-image is the old figure that we drew, okay, or the old figure, the starting figure, okay? All right, so again, the sides are all proportional, so that's how we can make our ratios. So here's an example. A drawing of a school mascot is to be enlarged as shown on the right, so it can be painted on the gymnasium doors. What is the scale factor of the dilation? So let's start by writing the ratio that compares the lengths of the sides of the two images. Okay? Now, in case you don't know, you can sit there and count the boxes, okay? You can go 1, 2, 3, 4, 5, 6, okay? Or you can just do 9 minus 3 to get 6, okay? That's the length of the original, that's the length of the dilation. This is the dilation because it's the school mascot is to be enlarged. So if it's enlarged, this is our image, okay? This is our dilation. So the length of our dilation is 6, or you can just sit there and count the boxes. Doesn't matter. So you can do 9 minus 3, or you can count the boxes across. Versus the length of the original. Well, how many boxes does it go across down here? Looks like it goes across 2, which makes sense because your ordered pairs are 3, and your ordered pairs x coordinates are 3 and 1. So you can just subtract those 2, right? In other words, here you're finding the change in x, right? The horizontal change between these two ordered pairs. Same thing here, horizontal change. How many boxes are in between? 9 minus 3 is 6. 3 minus 1 is 2. So 6 over 2 gets you 3. So your scale factor of the dilation is 3. And if you don't believe me, you can just double check. If down here the side length is 2, okay, and here the side length is 6, well, 6, okay, is 6 is 3 times the size of 2. Again, over here was 6, over here is 2. 6 is 3 times the size of 2. That's why our scale factor is 3. Concluding thoughts. Dilations produce images that are similar, okay? Just recall what that word means. It means same shape, but not necessarily the same size. If the scale is greater than 1, it is an enlargement. If it's between 0 and 1, it's a reduction. If it's 1, then it's the same. And finally, scale factor is determined by the ratio, the side length of the image over the side length of the pre-image. All right, thank you for watching. I hope you learned about dilations.